giants. Now it was so before we were giants, there were subgiants, and where the hydrogen in the center of the suns was used up. And previously in the main sequence of suns, the longest phase, where the hydrogen in the center is so hot at 10 million degrees Celsius, but it's moving so fast that it is overcoming its electrostatic repulsion. The hydrogen doesn't want to come together. But it is so hot that they're moving so fast that they come together, fuse, and becoming helium. So two hydrogen coming together to helium. That nuclear synthesis, that stellar nuclear synthesis, creates an outward radiation force. And that keeps it in balance, the star. There's pretty much the same force of gravitation to the center as there is through the thermonuclear reaction with stellar synthesis to the outside. Now there's no hydrogen anymore left. All the hydrogen was fused together to become helium. And the core starts to shrink. There's no outward force anymore. It shrinks. While it shrinks in this subgiant phase, the hydrogen that was on the outside, and the inside is all used up, but on the outside is still hydrogen. It's coming closer to the core, and it is enough pressure and again and heat to come again together with hydrogen and expanding. So the core is shrinking, the outside is also shrinking, but when the hydrogen comes together and is expanding again from the outside. All over, the core is shrinking, the overall dimension is expanding. And what is happening now? Now the core is shrinking and the core gets hotter because it's shrinking. The core shrinks and the core reaches 100 million degrees Celsius. And now it's hot enough, not just for the hydrogen to fuse together, that was 10 million degrees. Now the hydrogen is used up, the helium can fuse. There's a lot of helium ash, a lot of helium after the hydrogen is fused. Now at 100 million degrees, after it had contracted more and more, the helium can fuse to become carbon and oxygen. And again, it starts from the beginning and an outward force is happening again. Now the helium is fusing at 100 million degrees Celsius, an outward force is created, and that poofs off the outer layer, expanded layers as a planetary nebula that thing gets even bigger and poofs out a part of it. Now it's a giant. And these giants, they are 1,000 or 10,000 times as bright as a normal sun, and they are also tens or hundreds of times bigger as normal suns. The sun is expected to do it also. After some time, it is in its main sequence, it will come into its subgiant phase, it will come together, the outward is expanding, and suddenly at the center it's hot enough, the hydrogen, the helium is fusing together, and an outward force the thing will expand to 200 times its size. They are also blue ones, not all are red. Now, that is according then to Mark A. Garlick's Cosmic Mimicry book on the page 44 and 45. Hi and welcome. I'm trying to learn Heliology, today giants, and after we've done it, we're gonna do wrist training. And if you participate in the wrist training, then it's at your own risk. Giants, geriatric stars. Subgiants may be dramatic, but they are puny compared to the stars that they are destined to become. A subgiant's core is contracting all the time and thus heating up as it does so, because it's too big and the gravitational force is, the gravitational constriction is, contraction. The gravitational contraction is stronger than the outward force over. Now, a subgiant's core is contracting all the time. So the core of a subgiant of a big star is contracting all the time, and thus heating up as it does so. So the core is heating up. Once the core temperature is high enough, so much energy is generated that the radiation pushes on the star's outer layers and puffs them up to even greater dimensions. So radiation is pushing against the outer layers of the star, and it pushes out into greater dimensions. I still don't really understand what radiation is. But it is so hot that the radiation is pushing off the outer surface of a star, and it's not just there, but it's pushed out. The star swells into a monstrous caricature of its former self. With a typical diameter of a few dozen to hundreds of times larger than a normal. Now it makes a lot of sense why stars could become a black hole. I think this is the case. The star swells into a monstrous caricature of its former self, with a typical diameter of a few dozen to hundreds of times larger than a normal main sequence star, and 1,000 to 10,000 times brighter. These stars are known as red giants. So they are 100 times bigger than the Sun. I'm having right now a little compassion with the Sun, but it's so small, it's just burning. It's just a little orange and yellow burning. It's not like that. No, hundreds of times larger, and thousands or 10,000 times brighter than a normal star. And they are known as red giants now. When the Sun reaches the end of its life, it will expand into a red giant with an unexpected diameter of around 200 times its current size. So the Sun, so a normal main sequence star. So when the Sun reaches the end of its life, it will expand into a red giant, also with an expected diameter of around 200 times its current size. So the Sun, the one with the solar system where the Earth is, should expand 200 times of its diameter. That is pretty big. Easily large enough to engulf the innermost planets, possibly including the Earth. But that should happen only a few billion years in the future. Now, the Sun should get very big, and 200 times of its size it has right now. Eventually, with its core constantly shrinking as it runs out of reactionable fuel. So the core is shrinking because it doesn't have any more the stellar nuclear synthesis with the hydrogen forming to helium and having an outward force. The hypostellar synthesis, what was it? Hydrostatic equilibrium. They're having also supergiants. We are just by giants. Now, in the core shrinking, constantly the fuel is running out, hydrogen is running out, its internal temperature will reach a staggering 100 million degrees Celsius. 100 million degrees Celsius. That's the magic number needed to fuse helium ions together. Suddenly, nuclear reactions begin anew, this time feeding on the helium and creating a new-ish carbon and oxygen. Where we have it, and number 3 and 4 are created. Oxygen is 8. I don't know. Now, previously there was always hydrogen pressed together and becoming helium. Now the hydrogen is all used up and the core shrinking because there is no longer hydrogen fusing to helium and having an outward force. It is shrinking. It shrinks more, it gets hotter, it gets 100 million degrees Celsius. 10 million degrees Celsius are enough that hydrogen comes together, pressed together to become helium. Hydrogen has always one proton come together, become helium with 2. And now 2 helium are pressed together, and because it's 100 million degrees Celsius, and they're becoming carbon and oxygen. The core, alive once again, spews a fresh energy outwards, puffing out the star's outer layers even more until they start to escape from the star altogether, forming a planetary nebula. See page 106 and 7. Whatever I say so. Now the helium pressing together, giving carbon and oxygen, that has again this outward force, and that pushes now this outward escape, push the outward force, whatever it was, even more out and becomes some type of nebula. Generally, astronomers use giant to describe stars that are much larger than main sequence stars of the same temperature and hence color. Do they have now the same temperature or not? We use it to describe stars that are much larger than main sequence stars of the same temperature. So they're having the same temperature as main sequence stars, but they are much larger and having therefore a different color. So not all giant stars are red. LQ1, a star in the constellation of Taurus, is a blue giant that has exhausted the hydrogen in its core and has swollen beyond its main sequenced radius. It is on the way to become a red giant, as are most other non-red giant stars. For many stars, including the Sun, a red giant is the end point of stellar evolution. However, for the most massive stars, heavier than about 8 to 10 suns, the end is even more impressive. So we're saying stars like the Sun will then end basically as these giants and ending then as a nebula. They can be also blue. And there are some suns who are bigger, 10 times as heavy as the Sun. And they're having a more impressive end. When the Sun reaches the end of its life, it will expand into a red giant with an expected diameter of around 200 times its current size. A blue giant star, powerful and ultra-luminous, ravages the surface of this nearby rocky world. It ravages the surface of this nearby rocky world. These stars can pump out 10,000 times as much energy as the Sun. But with this an illustration. No, 10,000 times as much energy as the Sun. That was the giant part. We're going to come back in the next part. I think we're going to read maybe actually on subgiants, white dwarfs, neutron stars, black holes, and B stars, and flare stars, and brown dwarfs, and camaraderie of the stars in your chapter. Now, we're going to come back. I don't know, maybe we're going to read on before we're going to do a presentation about the giants, or we're going to do directly the presentation about the giants, I don't know. If you were here for Heliosites, you can go directly to the next part. Heliosites, maybe I'm going to read on, or read again and try to do the presentation about giants. If you stay here and participate in the wrist training, this bit at your own risk. Good, let's stay with standing stance, hand next to the body, the fists, and down the spotlight. And to the inside. Flat hands inside and outside. The magician. Now we're having 3 rules. The first rule is just stopping immediately as soon as there's pain. Flat hands open and close. So stop immediately as soon as there's pain. And next exercise, hands out and down. The second rule is that we go only as far as we can go with a little bit of effort. And the third rule is that we're not overdoing it. We just want to strengthen, not to exhaust. Fists to the inside. The triangular castle architect. And back again. And the next exercise with the T-Rex in the gym. You can do it with the tennis ball out. Just press on it. Release and press. And press again. Switch and press. Release and press. Then again, press. And the next exercise, a cautious big bang. Press the fingertips on top of the fingernails of your hand and go slowly. Close it. And switch, and open, and close. And now the field daisies in your symphysis recta. Fists and open. And now the crab anxious to have fever. You can take a break whenever you want. For example, now. Press on the outside. So fist down to deflection, press on the outside. Pull on the outside. Outside. Bottom. Outside fist down to deflection and press on the inside. Outside. And now the Basco bridge. Flat hands and bend them down. Out. And now the frog testing water temperature. Hands down with flat fingers. You can skip this exercise if you like. Up strong fists. You just want to strengthen, not to exhaust. Down, up, again down, and up. And now the claw. Flat hands and claws. Try to spread the fingers apart. Open and close. Open and close. One last one. Arms to the side, down at the flexion, down. You can do this exercise also slow. Up, turn around, on. And now, arms in, strong fists, in the flexion, out, extension, flat fingers. In strong fist flexion, out, extension, flat fingers. And in, and out. One last row. And now with the ice axe, flat hand, bend it into knuckles and press onto all 4 fingers. Other hand, bend it and press onto all 4 fingers. And now the sundial, you can use a sock or something else. Have it with a load arm and a flexed wrist. Out, let it fall down. Try to catch it again. And one level down. On the other side. And last exercise. Long arms, strong fists, and these fists in flexion. Out extension, flat fingers. In strong fist flexions. And out flat. Finger in. And out. One last round in. And out. And now a floor. Go with moderate pressure over the middle part of the lower. And on the other side. And that was Wristtraining. I thank you very much, and next.